This video clip describes how to use exponential equations to generate table data. If an ant colony has 1,000 ants and grows at a rate of 20% per month, the equation would look something like this. A for the number of ants equals 1,000 times 1.2 raised to the m power, m representing the number of months. The 0.2 corresponds with the 20%. The 1 would be all of the ants that we had before, plus the 20%. So the 1.2, that's why the 1.2. So to fill out a table that has the number of months in one column, we could fill out the other column. Well, month 0, 1.2 raised to the 0 is 1, so 1,000 times 1 is 1,000. 1,000 times 1.2 raised to the first power, 1.2 raised to the first power is just 1.2, so this one is 1.2 times 1,000, or 1,200. 1.2 raised to the second power is 1.2 squared. In our calculator, we will type in 1.2. We're going to raise it to the second power, and that is 1.44. And then let's multiply by the 1,000 that we started with. Okay, so 1.44 times 1,000 is 1,440. Come back to this page, 1,440 ants to the 8th power. Now 1.2 raised to the 8th is 4.2998. If I multiply that by 1,000, I get 4,299.8. Well, we're talking about ants, so we're talking about whole numbers. If I round that up to the nearest whole number, that is 4,300 ants. So if a car is worth 10,000, loses 10% in its value per year, the equation for its value could be written like this. V, representing the value, equals 10,000 times 0.9 raised to the t. So the full value would be 1, multiply 10,000 by 1. If 1 minus 0.1, that 10% would be 0.9. So if I multiply by 0.9 every year, then I raise that to the t power for how many years. So in a table, 1,000 times 0.9 raised to the 1 would be 1,000 times 0.9, which would be, or 10,000 times 0.9, which would be 9,000. 10,000 times 0.9 squared. So 0.9 raised to the second power times 1,000 is 8,100. So 0.9 raised to the 7th power is 0.478 times 10,000 is 4,782.969, or 97 cents at the end there. 4,782.97.